So for the Poisson distribution, it's a little bit different from the binomial distribution because for the binomial distribution, you're focused on how many experiment are they doing. So, because if you remember for the binomial, you're focusing on n many trial. So for the Poisson distribution, it's a little bit different because you're not focused on the n many trial. You're focused on a time period. So we're going to be focusing on a fixed length, which is t. So for the Poisson distribution, kind of way to tell the difference between a Poisson and a binomial distribution, a Poisson distribution would tell you a range of time. So it will tell you between like 5 o'clock to 8 o'clock, or it'll tell you from Monday all the way through Friday. So it'll give you a range of time versus when you're doing a binomial distribution will tell you exactly how many trials are we doing. All right. Any questions so far in regard to the difference between a Poisson distribution and a binomial distribution? Cool. All right, righty then. So let's go over a Poisson distribution. So X represent how many success do I want? So that still represent the same thing. Ooh. So yeah, so X still represent how many success do we want? Then we have T. T correspond to time. So the time just kind of go along with the lambda, because time you can tell like how much time has passed, like has how many hours have passed, how many minutes have passed, how many days have passed. Lambda is this symbol over here, and they just represent how many success do we want for a time period. So lambda gonna tell us, hey, we want 5 success in this hour, or we want 5 success for this day. So lambda gonna represent how many success do I want. And lastly, E, this is a constant. So you're not gonna substitute anything in there. Pretty much it's like pi, where pi is equal to 3.141. E is a constant number, so the constant number is 2.7 something. So instead of you putting 2.7 blah blah blah, you're gonna put E for that value. All right, so that's the formula for Poisson distribution. That will all of the variable represent. Any question in regard to that so far? All right, so let's go ahead and do some problem. So for the first problem, it says if a bank receive on average 6 bad check per day. All right, so the 6 bad check per day, that would correspond to lambda. So it'll be 6 bad checks per day. All right, so that's all the information they're giving us in that first sentence. They're giving us what lambda is equal to. So for part A, it says, what is the probability that the bank will receive 4 bad check on a given day? So for this one, if you kind of notice, they don't tell us how many check do they receive a day. They just tell us what's the probability that they receive 4 bad checks. So for this one, T will equal to how many days have passed. So they say a given day, so that means it's for 1 day. So T is equal to 1 day. How many bad checks do they want to see for that 1 day?
4.
4. Boom. All right, so what we're gonna go ahead and do, we're gonna go ahead and just substitute into our formula for Poisson distribution. So we're gonna say P of X is equal to 4, which is equal to lambda, which lambda is equal to 6, multiplied by T, which is 1. And we're gonna do that to the X power, which is 4. Then you divide that by x, which is 4 factorial. All right. Any questions so far? I got any of that? Okay, so then if you look at it, it says e, which e is a constant. And you do e to the negative lambda, which is 6 times 1. All right, so I'm going to go ahead and simplify this. So 6 times 1 is just 6, so I'm going to put 6. So you put 6 to the 4th power divided by 4 factorial. If you remember 4 factorial is equal to 4 times 3 times 2 times 1, which is 24 e to the negative 6. Everybody got, I got 6 to the 4th power divided by 24 times e to the negative 6. So that's pretty much as far as you could go. Up next, we're going to go ahead and we're going to use the calculator. So let me share. So we're going to do 6 to the 4th power. We're going to divide that by 24. And if you have your calculator, you should notice right here where it says E. This is the E I was talking about. So you press E. And then you just make that to the negative 6 power. And if you do that, you should get 0.1339. All right, but that's it for A. Any question in regard to A? And also, if you want to double check your answer, there's a function in ClassCalc that lets you double check your answer. So if you go to stats, if you go to distribution, if you look right here where it says Poisson distribution, just click that. Oops. Go to stats, go to distribution, go to Poisson distribution. And if you look at it, the only thing it asks for is mu. So mu in this case is lambda times t, which we got to be 6. So you choose PDF, you choose 4. And if you look, it gave us the exact same answer that we got by doing it by hand. Any question for A? All right, so switch it over and let's do B now. All right. So lambda is still 6 per day. Let's do B. So B says, what is the probability it will receive 9 bad check in any given 2 days? Okay. So for this one, what is my t equal to now?
2.
Yeah, t is equal to 2. Good. How many bad check do I want?
12. 9.
9.
Yeah, you want 9 bad check. All right, everybody good? Lambda is equal to 6, t is equal to 2, and x is equal to 9. All right, so let's go ahead and let's find this. So for this one, you want to be careful because you want to use these two to get mu. Because mu is equal to lambda, oops, lambda times t. So this is equal to 6 times 2, which is equal to 12. So that should make sense to you because it's going like, if I'm not doing it for 2 days, now the amount of batch check that I should see per day should double. So if in one day I see 6 batch checks, now in 2 days I should be seeing 12 batch checks. So when we go back to class cal, we're going to use mu is equal to 12, and we're going to use x is equal to 9. And for this one, should we use PDF or CDF? If you just had a guess.
PDF.
Yeah, you use PDF. Because remember, PDF, you always use it if you only have a singular x value that you're finding it for. If you have multiple x values that you're finding for, then you want to use CDF. So let me switch over to class calc. So the only thing I have to do here is just change what my x value is. So we're going to change it from 4. We're going to change it to 12. Well, we're going to change it to 9. But also you want to change your mu from 6 to 12. So it is important that you switch the mu because you do want to adjust the mu to be 12. Because if you put 6, it will give you an answer that is incorrect. All right. So if you look at it, you should get the probability that x is equal to 9 is equal to 0.0874. And that's the answer for part B. All right, so let's just see. So for C, it says, what is the probability it will receive at least one batch check every 2 hours? All right, so for this one, you have to be careful because right now the time is going to change, but also our x value, instead of it being one singular x value, it could be multiple value. So let's do the time. So for this one, it says one batch check every 2 hours. So it's not giving us a whole day anymore. It's saying 2 hours of that day. So it said a business day is from 8 a.m. to 6 p.m. So if a business day is from 8 a.m. to 6 p.m., how many hours are they open?
$10.
Cool. Open for 10 hours. Cool, perfect. All right. So if we want to find the probability, well, sorry, if we want to find the time, we know we only want them to be open for 2 hours out of the 10. So what should I put for T? Well, they're going to be open 2 hours out of the 10. So T will be equal to 1 out of 5. Any question where the 1/5 come from?
No.
All right. So for this one, lambda is still 6. So if I want to get what my mu is equal to, I'm going to have to do, well, T times lambda, which is equal to 1 out of 5, times 6, which is equal to 1.2. Yeah, it should be 1.2. All right, so that's my mu. So we're going to use this once we go to class calc. But up next, what we want to find is what is my x value? So for this one, it says x has to be at least one batch check every 2 hours. So what's the lowest my x could be?
Two.
Well, if it says at least one, that means one has to be the lowest. So that means we have to get 2, 3, 4, 5, 6, 7. So the one bad thing about Poisson distribution, it doesn't have a limit. So like in binomial distribution, we had a limit, so it could only go to n many. But for a Poisson distribution, pretty much it could go to infinity. So for this one, let's see how we're gonna do this for class calc. So we know mu is equal to 1.2. Let's see how we're gonna put our x value. So let me switch it over to class calc. All right, so the first thing I'm gonna do, change my mu from 12 to 1.2. We'll readjust that. And then instead of doing PDF, now we're gonna do CDF. So if you look in class calc, they have the infinity symbol right here. So we're gonna just leave that to infinity, and we're gonna say 1 to infinity. So if we do 1 to infinity, we get probability that x is greater than or equal to 1 is equal to 0.6988. And that's what I'm going to put for my answer once you're able to see it. So let me switch it over. Everybody got, I got the 0.6988. All right, so let me switch it over to my iPad. And that's it for C. Any question for C? All right, let's do D. So for D, says what is the probability it will receive at most 9 bad checks in any given 2 days? So for this one, time, how much time has passed? Or for what time period are we doing it for?
2 days.
2 days. So we'll put t is equal to 2, lambda is equal to 6. So if I want to find mu, mu will be t times lambda, which is just going to be 12. For this problem, what's going to be my x value? Or do I have multiple x value? Well, for this one, you should have multiple x value because the keyword here is at most. And most mean that's the highest it could go, but it could be anything lower than that. So we're gonna go 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we're gonna find the probability that x is less than or equal to 9. So if I want to find the probability of x equals 0 all the way through 9, which one should I use, PDF or CDF?
CDF.
So we're using CDF. All right, so I'm gonna go transition over to class calc, and I'm gonna go and make these calculations. All right, so the first thing I'm gonna do, change my mu to 1.2 to 12. I'm gonna adjust the picture. So now we're still gonna be doing CDF, but CDF we're gonna go from 0, and we're gonna switch it to 9. So if you look at the probability that we get for that Poisson distribution, we get 0.2424. And that'll be the final answer for the Poisson distribution. And that's the answer I got for D. Any question for D? All right, so let's move down. All right. So just something that I kind of already gave you. I already told you what the mu is equal to. So if you look right here, it says mu is equal to just lambda times t. But if you want to find standard deviation, you take the square root of lambda times t. All right, so let's go ahead and just do this problem. So for this one, it says, what is the mean and standard deviation of a bad check for a given day? So we're doing this for a given day. So that means t is equal to 1. It means lambda is equal to 6. So if I want to find mu, you do 1 times 6, which is 6. You also want to find the standard deviation. So we're going to do standard deviation of square root of 6. Let's do that. The square root of 6, you get 2.45. And that's it for B. Oh, sorry, that's it for A. So let's do B. So for B, it says, what is the mean and standard deviation of a bad check for any given 2 days? So now T is equal to 2, but lambda is still 6. So for mu, we'll say 2 times 6, so you get 12. If you want to do standard deviation, you do square root of 12. And you get 3.64, oops, 3.464. And that's it for B. Any question for B? All right, so let's do C. So for this one, if you remember, we said T is equal to 1 over 5 because you got 2 over 10. Lambda is still equal to 6. So if I want to find mu, you do 1 out of 5 times lambda, which is 6, and you get 1.2. If you want to find standard deviation, you say square root of 1.2. So square root of 1.2, you get 1.095. And that's it for C. So for those finding the mean standard deviation is that bad, you have to just make sure you follow that formula. And the formula is not that bad. It is multiplying t times lambda. And then to find standard deviation, you take the square root of t times lambda. Any question for C? All right. All right, so let's do this problem. And then that's it for today. So for this problem, it says a life insurance salesman sell on the average 3 life insurance policy per week. Calculate the probability that in a given week he will sell, so on and so forth. All right, so how many life insurance policies does this person sell?
3.
Cool, 3. Cool. So 3 per week. So for part A, it says find the calculate the probability that in a given week he will sell 5 policies. So for this one, time is equal to 1 because we want to do it for a given week. So that means mu will equal to what? What's lambda times t?
3.
Yeah, 3. What's x? So how many policies does he want to sell for that week?
5.
All right, so let's go to class calc and let's do mu is equal to 3, x is equal to 5.
And PDF.
Yeah, and you want to do PDF because you only want x is equal to 5. You only want one outcome versus multiple outcome. All right, so we're going to change mu from 12 to 3. We're going to say this is PDF. So for PDF, we are going to put 5. So when PDF is 5, you get probably the x is equal to 5 is equal to 0.1008. And that's it for A. Any question in regard to A? All right, so let's go back to my notes and let's look at part B. Well, I don't really need to look at my notes. So if you look at part B says at least 2 policy. So if it says at least 2 policy, that means x is equal to 2, but it could be 3 policy, 4 policy, 5 policy.
You can
All
still
the way-
see the class calc.
What was that?
We can only see class calc. We can't see your notes.
Oops.
See, I'm paying attention.
Nobody was judging you on paying attention, Samantha. Cool. All right, so there go the notes. So at least 2 policy is 2, 3, 4, 5, all the way to infinity, correct? So for this one, which option are we going to use, PDF or CDF?
CDF.
Yeah, CDF. So you want to use CDF because you have multiple outcomes that you want to find the probability for, just not one. So let's switch over back to class calc and let's just adjust our thing. So for this one, we're still going to leave it as 3 for mu. The thing we are going to change it from PDF to a CDF. So we're going to say the lowest we want it to be is 2, and we're going to make it go all the way to infinity. So you get probably that x is greater than or equal to 2 is 0.8008. All right, and that's it for part B. Any question for part B? All right, so let's do the last one of the day. All right, so for part C, it says, assuming that there are 5 working days per week, what is the probability that in a given day he will sell 1 policy? Okay, so for this one, you do want to be careful because they are changing the time, because instead of it being per week, you want to find the probability of a day. So let's find the time. So if we just want to find 1 day of the week, how would I write that as a fraction?
1/7.
Well, for this one, you have to be careful because it says that there are only 5 working days. So if they work Monday all the way through Sunday, it will be 1/7. But since they only work 5 days of the week, it'll be 1/5. Does that make sense?
Yes.
All right, so that means lambda is still going to be 3, but what's going to change is my mu, because mu will now be 3 multiplied by 1/5, which will equal to 0.6. So once I go to class calc, I have to make sure to switch my mu from 3 to 0.6. And also for this one, how many policy do I want to sell in a single day?
One.
Yeah, 1. So what we're gonna do, we're gonna find the probability that x is equal to 1. So since we only want to find one outcome, this is gonna be P, D, F. So I'm gonna switch it over to class calc. So first thing I want to do, change the 3, and we're gonna change it to 0.6. For this one, we don't want to do a CDF anymore. Actually, we want to do a PDF. And for this one, we're going to do when x is equal to 1. And if you look at that, that gives us 0.3293. And that's it for that last problem. Any question in regard to that last problem?